Okay, so hello everyone. This is a theorem on homomorphism. So let's say f from G to G dash is a homomorphism. Then the kernel f is a normal subgroup of G. So basically we need to prove that f is a normal subgroup of G. Now, in order to prove any theorem and to learn it, what you need to do is you need to create a roadmap of every theorem, like I have done in this theorem. So what are the steps that we need to do in this theorem is, firstly, in order to prove a group subgroup a subgroup normal, then we before that we need to prove it as a subgroup. So before proving it a subgroup, we need to prove it as a non-empty subset of G. So the very first step is to take k is equals to kernel of f is a non-empty subset of G. So firstly we need to show that k, which is a kernel of f, is a non-empty subset. Secondly, we need to show that k is a subgroup, non-empty subset, then a subgroup. And how are we going to do this? We'll be taking a comma b from k, and then we'll prove that a b inverse belongs to k, because this is how a subgroup can be proved. And the third thing is that we need to prove x inverse belongs to k. So in order to prove it, that k is a normal. Okay, so let's start with the proof. Let E be the identity element of G and E dash be the identity element of G dash. Okay, now, and you know that f from G to G dash is a homomorphism. Right. Now we'll be defining k. What is k? So k is nothing but the kernel of f. So what is a kernel? You know that k has all the elements of G for which those elements are mapped to identity of G dash, right? Okay, now since E belongs to G, okay, so we are doing with the first step. We are showing that k is a subset of G, non-empty subset, right? So since E belongs to G, f of E will definitely map to E dash of G dash. So this implies E belongs to K. So what E belongs to K shows? It shows that K is non-empty. Okay, moving to the second step. Okay, so I'm writing these things, but you need not to do it in the examination, just writing it to make it simpler. Now we're going to show that K is a subgroup. So we'll be taking a comma b from K. So if a comma b belongs to K, now I say that these a and b comes from G, and I say that a comma b belongs to K, which means f of a is mapped to E dash, f of b is mapped to E dash. So I can write it directly that f of a right. Now we're considering it. Okay, we're not doing anything else. So f of b inverse. Now need to know where is this thing mapped. Let's say if this thing is mapped to E dash, then that will show that AB inverse will belong to this K. This element AB inverse will belong to K. Now if you have any doubt that where does this AB inverse come from, so we know that AB comes from K. K is a subset, non-empty subset of G. So that means G is a group and K is a subset, right? So this is it. Now moving forward, we have F. Like we are using the property of homomorphism because it was said that F from G to G dash is a homomorphism. Okay, so you know this property of homomorphism, I believe, right? Now, what is f of A? You all know this clearly. E dash into what is f of B? E dash clearly. E dash inverse is E dash into E dash is E dash, right? And it is not into, I'm sorry, this is the operation, because here the operation is not defined, but yet you know that E operation E dash is E dash, sorry, this. Yeah, so what we found that f AB inverse is equals to E dash. Now what does it show? It simply shows that AB inverse belongs to K, because all the elements from G were mapped, if mapped to E dash belongs to K. So here AB inverse belongs to K. So what does it tells about K? Therefore K is a subgroup of G. Now moving to the third step, we'll be proving that K is a normal subgroup of G, right? So let X belongs to G. You remember what you need to show, this thing. Okay, so again we consider f x A inverse. We're considering this, okay? Very simply writing down with the help of homomorphism. Okay, I'm just not taking it one by one. You can rather show it one by one. So f of A, you know, is E dash, and this f of x inverse, you have no idea yet. So we'll be writing it simply. Now E dash is simply nothing, so you can remove it. What you get, what you're left with is this. Now fx into fx inverse is E dash. Okay, so what I hope you believe that again this thing belongs to K, because this is mapped to, function of this is mapped to E dash of G dash. Therefore x A x inverse belongs to K, which shows that K is a normal subgroup of G. So a theorem becomes extremely easy if you break it down into the roadmaps, right? So if you need any roadmap of any other theorem, please do mention. Thank you.